And the task before us now is to keep NASA heading onward and upward. Artemis, DART, the James Webb Space Telescope.
NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
In the wide expanse of the universe, a little spaceship continues its historic voyage. NASA warns that Voyager 1 spacecraft, launched more than 4 decades ago, has made an impossible discovery after 45 years.
15 billion miles away, the Voyager 1.
Its mission, which originally intended to study the outer planets of our solar system, has grown into a journey of discovery, providing insights into the secrets of the universe. However, recent irregularities in Voyager 1's data broadcasts have baffled scientists, raising concerns about the spacecraft's current mission and the obstacles it confronts. The problem with communication. NASA's Voyager 1 probe, launched in 1977, is continuing its remarkable trek into interstellar space, but new data oddities have perplexed scientists back on Earth. The spaceship, which is nearly 45 years old, is facing issues that exceed its anticipated lifespan, including a breakdown in its attitude articulation and control system. Despite being over 14.5 billion miles distant, Voyager 1 communicates with Earth, albeit with some delay due to the great distance. The Voyager project is planned to investigate the far limits of our solar system and beyond. Voyager 1, along with its twin Voyager 2, set out on its historic journey, becoming the first human-made objects to reach interstellar space beyond the influence of the Sun. However, in recent years, Voyager 1 has faced unanticipated obstacles. The fault that affected the spacecraft's orientation in space resulted in the transmission of invalid data back to Earth. This anomaly, discovered by NASA's engineering team, presents a substantial challenge to the mission's continued success. Suzanne Dodd, project manager, acknowledges the situation's complexity, but remains optimistic about finding a solution. She points out that the spacecraft's age, which is considerably beyond what mission planners expected, along with the extreme radiation environment of interstellar space, presents considerable hurdles for the engineering crew. Communication delays worsen the problem, as signals take more than 2 days to reach between Earth and Voyager 1. Thomas Zurbuchen, NASA's Associate Administrator for the Science Mission Directorate, compares the communication procedure to a slow conversation, which impedes efforts to efficiently diagnose and manage the spacecraft's problems. Despite these hurdles, NASA remains dedicated to tackling the problem, whether through prospective software updates or the use of redundant hardware components. Voyager 1's robustness is demonstrated by its previous reliance on backup equipment, such as thrusters that had been inactive for 37 years, until firing successfully in 2017. Meanwhile, Voyager 2, which launched with Voyager 1, continues to function regularly in interstellar space, giving crucial insights into the heliosphere and beyond. Both spacecraft have gone beyond their initial mission scope, representing humanity's deepest reach into the universe. The Voyager mission. In the late 1970s, NASA had ambitious plans to go on a grand tour of the outer planets, which included sending 4 extremely sophisticated spacecraft to Jupiter, Saturn, Uranus, and Neptune. However, these plans were blocked because of the anticipated exorbitant expenditures, which were estimated at over $1 billion. As a result, NASA reduced its mission and suggested launching only 2 spacecraft, Voyager 1 and Voyager 2, to study Jupiter and Saturn in more detail. This decision represented a fundamental shift in space exploration policy, prioritizing in-depth inquiry above broad planetary coverage. The original design of the Voyager missions was inspired by the successful Mariner spacecraft series. Initially known as Mariner 11 and Mariner 12, the spacecraft was renamed when NASA Administrator James C. Fletcher stated that they would be formally known as Voyager 1 and Voyager 2. Each Voyager spacecraft was equipped with cutting-edge equipment, including a slow-scan color TV camera, to take photos of the planets and their moons. They also carried a large collection of scientific instruments capable of recording magnetic, atmospheric, and lunar data, among other critical information about the planetary systems they would meet. Voyager 1 began its journey in 1977, following a successful launch. Despite being launched after Voyager 2, Voyager 1 traveled a speedier course, allowing it to leave the asteroid belt earlier. On December 15, 1977, Voyager 1 passed Voyager 2, marking an important milestone in its interstellar journey. This spacecraft's journey took it into interstellar space, beyond the heliosphere, where the effect of the sun's energetic particles and magnetic fields faded. At Jupiter, At a distance of around 165 million miles, Voyager 1 arrived at Jupiter in 1979 and began its Jovian imaging mission. This mission allowed the spacecraft to take photographs of the gas giant and its moons that had never been seen before. The images that were taken revealed a turbulent environment that was typified by swirling storms and complicated cloud formations. These shots provided scientists with essential information regarding the meteorological processes that occur on Jupiter. Notable is the fact that Voyager 1 captured a series of photographs over the course of 100 hours, which resulted in a breathtaking color time-lapse movie depicting Jupiter's 10 rotations. A number of remarkable discoveries were made by Voyager 1 as it proceeded further into the Jovian system. One of these discoveries was the existence of a thin ring that would surround Jupiter. This finding, in conjunction with the discovery of 2 new moons, Thebe and Metis, assisted us in gaining a deeper understanding of the intricate dynamics that are present in the vicinity of Jupiter. On the other hand, the most fascinating discovery was made by Voyager 1, as it was attempting to make contact with Io, which is one of Jupiter's moons. The photographs that were provided by the satellite showed a landscape that was characterized by vivid yellow, orange, and brown hues, with towering volcanic plumes giving it a distinctive appearance. The volcanic activity of Io, which is among the most powerful in the solar system, revealed the presence of sulfur-rich chemicals that were erupting from the surface of the planet. In spite of the fact that it was launched with a high degree of risk, Voyager 1 was able to successfully navigate the dangers of space, providing scientists with vital information as well as breathtaking photos of Jupiter and its many moons. Following this, Voyager 1 turned its attention to Saturn, marking the beginning of a new phase in its voyage through the cosmos. Near Saturn, the Voyager 1 spacecraft made adjustments to its trajectory when it approached Saturn in 1979 in order to attain a more accurate track. During this approach, the spacecraft gathered a multitude of discoveries that would fundamentally alter our understanding of this gorgeous planet and its intricate ring system. One of the most significant findings from Voyager 1's research of Saturn was the identification of 5 new moons, including Prometheus and Pandora. These moons' gravitational interactions were responsible for the formation of the stunning patterns that can be seen in the rings. A comprehensive examination of Saturn's moons was carried out by Voyager 1 as it approached the gas giant Saturn. The results of this examination revealed a vast variety of frozen planets surrounding Saturn. Particularly noteworthy is the fact that the Voyager 1's observations of Titan, Saturn's largest moon, showed a thick atmosphere that conceals the surface from view. Through the use of infrared spectroscopy, researchers were able to identify the composition of Titan's atmosphere, which was mostly composed of nitrogen, with traces of methane and complex hydrocarbons occurring. This exciting revelation sparked debate about the likelihood of prebiotic chemistry on Titan, which in turn raised intriguing questions about the moon's capacity to support life from other planets. In addition, the close-up photos that Voyager 1 took of Saturn's moons, such as Mimas, Enceladus, and Tethys, revealed previously unknown information about the geological structures and surface compositions of these moons. As a result of the spacecraft's observations, it was discovered that the majority of these moons were composed of water ice. This finding highlights the amount of frozen bodies that can be found throughout the Saturnian system. As Voyager 1 said its farewells to Saturn and embarked on its journey across space, it left behind a path of groundbreaking discoveries and iconic photos that continue to astonish and fascinate people to this day. The pale blue dot photograph, which was taken in 1990 when the spacecraft returned its cameras to Earth from a distance of 3.7 billion miles, is considered to be one of the most important major contributions that it has made to the field of space exploration. The Earth appeared to be a solitary speck poised in the vastness of space in this stunning photograph, which served as a sobering reminder of the perilous survival of our planet in the midst of the abyss of the cosmos. The voyage that Voyager 1 took through the most extensive regions of the solar system is illustrative of the inexhaustible curiosity and resourcefulness that humans possess. The Voyager 2 and Jupiter. On December 10, 2018, NASA's Voyager 2 made history by becoming the second spacecraft to enter interstellar space. This momentous event represented a crucial milestone in humanity's study of the universe, when Voyager 2 joined its twin, Voyager 1, as the only man-made objects to travel into the immense emptiness between the stars. Voyager 2's investigation of Jupiter began in April 1979, when it began transmitting photos of the gas giant's fascinating atmosphere. Unlike its predecessor, Voyager 1, Voyager 2 made close passes passes over Jupiter's moons, including Europa and Io, giving scientists vital information about their geological properties. Voyager 2 took stunning photographs of Jupiter and its 4 largest moons, Callisto, Ganymede, Europa, and Io. One of the mission's highlights was a 10-hour volcano watch, while Voyager 2 flew by Io, revealing unprecedented detail about the moon's volcanic activity. Voyager 2's closest encounter with Jupiter occurred on July 9, 1979, at a distance of around 400,000 miles, allowing it to collect fresh information about the planet's clouds, moons, and ring system. The Voyager mission revolutionized our understanding of Jupiter's atmosphere by identifying substantial changes, such as movements in the Great Red Spot and changes in cloud formations. Scientists were able to map more than 80% of the surfaces of Ganymede and Callisto, 2 of Jupiter's largest moons, in astonishing detail by integrating photos from Voyager 1 and Voyager 2. Voyage to Saturn. Following the successful completion of its mission at Jupiter, Voyager 2 proceeded to Saturn, where it embarked on a journey into the solar system's most distant regions. In August of 1981, Voyager 2 made its approach to Saturn, obtaining breathtaking photos of the planet's unique rings and the interesting moons that orbit around it. During the course of its approach, Voyager 2 was able to take more detailed photographs of Saturn's ring system. These photographs included the elusive spokes and kinks that were discovered by Voyager 1. In addition, the spacecraft investigated Saturn's moons, such as Hyperion, Enceladus, Tethys, and Phoebe, shedding light on the geological characteristics and surface compositions of these moons. Traveling through Saturn's ring plane was one of the most challenging portions of the meeting that Voyager 2 had with the planet Saturn. As the spacecraft passed through the dense ring particles, it was struck by millions of dust grains that were only a few microns in size. This caused the dust grains to vaporize, resulting in the formation of puff plasma. In spite of these challenges, Voyager 2 was able to successfully traverse Saturn's ring plane and collect essential data regarding the structure and composition of the ring. Exploring Uranus. Following the successful completion of its mission at Saturn, Voyager 2 embarked on an ambitious journey to Uranus, becoming the first spacecraft created by humans to sail by the mysterious ice giant. The Voyager 2 spacecraft started its approach to Uranus in January of 1986, providing astronomers with their first close-up images of the faraway planet. When Voyager 2 successfully conducted a flyby of Uranus, it revealed a complex system of moons, rings, and atmospheric phenomena. This was accomplished despite the challenges that were associated with journeying through the outer solar system. While conducting the flyby, Voyager 2 discovered 10 new moons orbiting Uranus. These moons include Puck, Portia, and Juliet. Additionally, the spacecraft found 2 additional rings, which expanded the already diverse ring system of the planet. The slanted magnetic field of Uranus, which is 55 degrees off-axis and off-center, was also observed by the probe. This phenomenon revealed significant information regarding the interior structure of the planet, as well as the dynamics of its magnetic field. Evidence of a boiling ocean of water beneath the cloud tops of Uranus was discovered by Voyager 2 during its exploration of the planet's atmosphere. In addition, the spacecraft was able to capture stunning images of Uranus's moons, including Miranda, Oberon, and Ariel. These photographs provided scientists with valuable information regarding the geological characteristics and surface compositions of these bodies. It's time for our subscribers' pick. NASA warns that Voyager 1 has made an impossible discovery after 45 years. The pale blue dot refers to a photograph of Earth taken by the Voyager 1 spacecraft on February 14, 1990, from a distance of about 3.7 billion miles away. At the request of the astronomer Carl Sagan, NASA commanded Voyager 1 to turn its camera back towards Earth and take this photograph. In the image, Earth appears as a tiny, almost insignificant dot, less than a pixel in size, set against the vastness of space, highlighted by a sunbeam. Carl Sagan reflected on this photograph in his book, Pale Blue Dot, A Vision of the Human Future in Space, using it as a profound reminder of our planet's fragility and the unity of life on Earth. Here is an excerpt of his reflection. Look again at that dot. That's here. That's home. That's us. Encounter with Neptune. Neptune, the planet that is the farthest away from the Sun, was the destination of Voyager 2 after it had completed its historic flyby of Uranus. Voyager 2 made a close flyby of the distant planet Neptune and its mystery moons in August of 1989. Voyager 2 made a number of discoveries during its voyage to Neptune. These included the discovery of 6 new moons orbiting the planet, including Proteus, Larissa, and Despina, as well as 4 additional rings. which expanded the already diverse ring system of the planet. During its exploration of Neptune's atmosphere, Voyager 2 discovered that the planet's atmosphere is both dynamic and turbulent, with winds reaching speeds of up to 680 miles per hour. As part of the mission, comprehensive images were taken of the cloud patterns of Neptune, including the Scooter, the Lesser Dark Spot, and the Great Dark Spot. These photographs supplied scientists with essential knowledge regarding the processes that occur in the atmosphere of the planet. The finding of nitrogen ice volcanoes on Triton, the largest moon of Neptune, was one of the most sudden and unexpected discoveries that Voyager 2 made. The probe was able to capture breathtaking photos of the surface of Triton, which revealed a peculiar and scarred topography that was unlike anything that had ever been seen in that part of the solar system. Voyager 2's incredible journey across the solar system's most distant regions came to a close with the flyby of Neptune, which marked the end of the spacecraft's interactions with the planets via its stellar exploration, heliopause, and the interstellar space. The Voyager 1 and Voyager 2 spacecraft were on a mission unlike any other in space exploration history. Armed with a slew of scientific instruments and fueled by the constant hum of radioisotope thermoelectric generators, they set out on a magnificent expedition that would take them to the edge of our cosmic neighborhood and beyond. For decades, these intrepid travelers sailed through the blackness of space, passing past our solar system's gas giants Jupiter, Saturn, Uranus, and Neptune, with each encounter revealing fresh wonders and mysteries about the outer planets. However, their final objective lay beyond the familiar bounds of our solar system in the unknown area of interstellar space. The earliest indications of their presence came in 1992 when scientists discovered powerful low-frequency radio emissions coming from beyond the heliosphere, the huge bubble of charged particles that surrounds our sun. For months, the origin of these mysterious signals remained unknown, until researchers realized they were viewing the boundary between our solar system and the cold, dark expanse of interstellar space. Dr. Edward C. Stone, director of the Jet Propulsion Laboratory and Voyager Project scientist, expressed his enthusiasm over the discovery, remarking that it hinted at even more surprises for the Voyagers as they completed their trip. The radio emissions were thought to be caused by a cloud of electrically charged gas known as plasma expanding from the sun and interacting with interstellar gas beyond the heliopause, which is the boundary between the heliosphere and interstellar space. Scientists believe that heliopause indicated the furthest border of our solar system, beyond which the sun's influence decreased and the realm of stars began. However, determining its precise location was difficult, necessitating a thorough examination of data obtained by the Voyager spacecraft as they completed their voyage through space. Voyager 1 made history in August 2012 when it became the first human-made object to pass heliopause and reach interstellar space. The discovery was made public in a paper published in the journal Science the following year, which revealed that Voyager 1 had encountered a higher density of charged particles than is generally observed close inside the heliosphere. This discovery prompted significant issues concerning the nature of interstellar space and the dynamics of the heliosphere. Despite original assumptions, Voyager 1's investigations revealed that electron density in interstellar space was higher than near the Sun, a perplexing finding that called into question existing models of the solar wind and interstellar medium interaction. But Voyager 1's journey wasn't over. The spacecraft, equipped with a suite of scientific instruments such as a plasma wave subsystem and a cosmic ray detector, continues to transmit crucial data about interstellar space. It indicated that cosmic radiation in our galaxy's furthest regions was much stronger than previously anticipated, creating possible obstacles for future manned expeditions beyond our solar system. Voyager 1 made headlines again in December 2017, when NASA reported that the spacecraft had successfully used its backup thrusters to position itself, thanks to engineers' creativity and the ship's incredible resilience. With its primary thrusters deteriorating after nearly 4 decades in space, Voyager 1's successful maneuver proved the spacecraft's ongoing viability and extended its operating life by several years. Voyager 1 was not alone on its interstellar trip. Its twin, Voyager 2, followed a similar path, crossing the heliopause in 2007 and continuing to investigate the extreme regions of our solar system. In September 2017, Voyager 2 celebrated its 40th anniversary since launch, demonstrating the spacecraft's durability and the dedication of the mission team that continues to maintain its operations. Voyager 2, like Voyager 1, has made major contributions to our understanding of interstellar space, revealing new information about the dynamics of the heliosphere and interstellar medium. On July 2019, Voyager 2 activated its trajectory correction maneuver thrusters, assuring its continued capacity to connect with Earth and transmit crucial data from space. From their humble origins as distant specks in the night sky, they have evolved into beacons of knowledge, illuminating the darkest regions of our cosmic neighborhood and inspiring future generations to seek the stars. However, the Voyager's mission is far from over. They continue to sail through the immense expanse of interstellar space, reminding us of our place in the universe and the limitless possibility for human exploration. For as long as they can communicate with Earth, the Voyagers will act as our ambassadors to the stars, carrying the hopes and dreams of anyone who dares to travel into the unknown. The Golden Record, Europa Clipper mission, and potential life. The Voyager spacecraft carries a powerful message for possible extraterrestrial civilizations, an elaborate golden disc etched with symbols, audio recordings, and images that capture the spirit of humanity. These discs, created under the supervision of Carl Sagan, serve as a monument to human curiosity and desire to communicate with entities beyond our planet. These discs, 12 inches in diameter, are made of gold-plated copper for strength and longevity. They include symbols representing Earth's position relative to pulsars, as well as instructions for playing back with a cartridge and needle, similar to a vinyl record player. The audio recordings include greetings in 55 languages, a broad array of Earth noises, and 90 minutes of Western music ranging from classical masterpieces to legendary rock and roll hits. The voice is accompanied by 115 photos depicting life on Earth, ranging from magnificent scenery to the rich diversity of human civilization. These visuals, together with audio greetings from then U.S. President Jimmy Carter and then UN Secretary-General Kurt Waldheim, send a message of peace and unity to any prospective listeners throughout the universe. As of January 2024, Voyager 1 had traveled 136 astronomical units beyond Earth, making it the farthest object produced by humanity. Voyager 1 continues its solitary voyage across interstellar space, traveling at nearly 38,000 miles per hour relative to the Sun, and bringing with it humanity's hopes, dreams, and collective knowledge as it explores the immense expanse of the cosmos. Europa Clipper, NASA's ambitious project to examine Jupiter's enigmatic moon Europa, marks a huge step forward in humanity's quest to understand our place in the universe. This $5 billion spacecraft, set to launch atop a SpaceX Falcon Heavy rocket on October 6, 2024, is poised to transform our understanding of this cold world and its potential for life beyond Earth. Europa, discovered in 1610 by Italian astronomer Galileo Galilei, has intrigued scientists for centuries with its promise of a deep ocean concealed beneath an ice shell. This tantalizing possibility has led to Europa being heralded as one of the most likely locations in the solar system to look for extraterrestrial life. But first, let's take a look at the chronology of the Europa Clipper mission. The Europa Clipper spacecraft will follow a complicated trajectory, aided by gravity forces, to its target. Europa Clipper will first travel to Mars, after being launched from Florida's Kennedy Space Center. On February 27, 2025, it will reach the red planet and use its gravitational pull to slingshot back toward Earth. Then, on December 1, 2026, Europa Clipper will receive an Earth gravity assist, propelling it towards its final destination, Jupiter. The spacecraft is planned to arrive at Jupiter on April 11, 2030, where it will enter a long, looping orbit around the gas giant. Rather than directly orbiting Europa, Europa Clipper will keep a safe distance from the Moon because of the harmful radiation environment caused by Jupiter's enormous magnetic field. Instead, it will use an elliptical orbit to undertake near flybys of Europa while minimizing radiation exposure. But why is Europa such an appealing target for exploration? The explanation lies in the intriguing prospect beneath the ocean. Multiple missions, including Pioneer, Voyager, Galileo, and Juno, have found persuasive evidence of a large ocean beneath Europa's frozen surface. This ocean, which is thought to be between 2 and 20 miles thick, provides an intriguing habitat that may potentially support life as we know it. Europa Clipper's major goal is to determine the habitability of Europa's ocean. The spacecraft will conduct around 45 near flybys of the Moon to research its surface chemistry, geology, and magnetic field to determine whether the circumstances are conducive to life. But what exactly do scientists want to find? Marshall Stokczynski, a NASA postdoctoral scholar working on the Europa Clipper mission, explains the mission's goals. He argues that Europa's water is of special interest since it could harbor hydrothermal vents comparable to those found on Earth. These vents may supply the required energy and nutrients to support microbial life, making Europa a top target in the quest for extraterrestrial life. Europa Clipper is outfitted with a set of instruments designed to conduct in-depth studies of Europa's surface and subsurface. These tools, which include cameras, spectrometers, and ice-penetrating radar, enable scientists to collect information about the Moon's composition, geology, and possible habitability. However, investigating Europa presents unique problems, the most notable of which is the harsh radiation environment near Jupiter. To safeguard its sensitive electronics, Europa Clipper has an armored vault with 0.3-inch thick aluminum walls, similar to the design employed on NASA's Juno mission. This shielding assures the spacecraft's survivability in Jupiter's severe radiation environment, allowing it to complete its mission uninterrupted. Despite its amazing capabilities, Europa Clipper is not intended to directly detect life on Europa. Instead, its major purpose is to determine the Moon's habitability and collect data that will help guide future exploration operations. To detect indications of life, scientists may need to embark on a more ambitious mission that includes landing on Europa's surface, drilling through its frozen crust, and probing the water below. The Europa Clipper mission is a significant milestone in humanity's ambition to explore the universe. Scientists seek to uncover the mysteries of Europa's frozen surface and hidden ocean, shedding light on the possibility of life beyond Earth. With each flyby, Europa Clipper moves us closer to answering one of our time's most important questions. Are we alone in the universe? Thanks for watching. See you in the next one.